Friday fundamentals on the 2019 year. What we're going to show you this morning is SoftPlan that's been configured for um, Florida construction. So I have, if you can see here in your screens here, I have a Friday fundamentals project that I've already brought up, and I brought it up on my screen. And the first thing you're probably going to note is that my screen looks probably different than the ones that you're used to using, which is fine, but all that does is simply confirm the fact that SoftPlan is in fact fully customizable. So what we're going to talk about is why we're doing it this way and why the Florida Building Code has mandated so many different changes to the way buildings have to be constructed, especially in the peninsula of Florida, which is where I am. I'm in Daytona area. All that makes this much more fun is that I'm in Daytona presenting through Jim, who's up in Tennessee, who's broadcasting this out to everyone wherever you're located. But that said, we want to talk a little bit about the Florida Building Code and what's required in terms of construction technology, especially in the peninsula. And most of that is going to boil down to block construction, otherwise called CMU construction, CMU standing for concrete unit, concrete masonry unit, I'm sorry, and it's a concrete block especially. Some people call them cinder blocks, but there's no such thing as a cinder block. It's all done with concrete. As you move up the peninsula and get closer to the Jacksonville area and then migrate to the west out toward Pensacola, you're in a mixed environment. And in those cases out there, there's a lot of stick frame construction, 2x4, 2x6. Almost always, though, those homes are built, whether you're in the peninsula or whether you're out in the panhandle, those homes are going to be built on monolithic slabs, sometimes on stem walls if you're in a sloping terrain. We're going to discuss both of those. And then almost never is there a basement that's put in to a Florida home because the water table is so close to the surface that digging a basement would simply flood anyway before you could even build one. So that aside, there's a couple of things to keep in mind about the Florida Building Code, and that's the big key here is wind loads. So we're worried about high-speed winds. We had a hurricane that came through offshore, fortunately, last week, Hurricane Dorian. There's another one lined up aiming at us now. It hasn't got a name yet, but it will by Sunday, I'm sure. So what everyone worries about is hurricanes and having the roof come off or having a second story blow off, or simply having debris that's going to penetrate the home or penetrate through a series of openings, either windows, doors, or garage doors. So what's mandated is that you have to reinforce not only the block construction itself, but you have to find a way that will hold down and fasten second stories to first stories, roof systems to second stories, by using what are called hurricane straps. Simpson is a typical manufacturer. MyTech is as well. So we're going to talk about some of that. But what I really want to concentrate on here is we're not going to spend a lot of time on building out the interior of the building. I want to talk about methodologies in terms of accuracy for 2 points. One is to get the drawing done completely and accurately so that it makes sense for Florida construction. And secondly, I want to show you 2 different ways to measure bills of materials that would be used and calculated in a Florida environment. So with that said, let me just jump right in. First thing you're going to see on your screen is that my navigation tab is sitting over here on the left-hand side. And if you hover on it, it comes out. And if you slide off, it goes back in. I don't have a large screen at my disposal right now. So what I've done is, in this particular case, I've minimized it, pushed it off to the side. We're dealing with a main floor. That's going to be our first floor, bottom floor, whatever. And then here is a pre-launch of the building materials with no pricing, commodities only. This was not shipped with the original software. This is a product that I have developed over a period of years. And when customers come in and buy the program from me, we go out and install it for them in the Florida marketplace and modified it for Florida construction, including wall libraries and all the rest, so that as they begin their design process, they don't have to bend it or fix it or modify it. They can, from the get-go, start designing and building in a Florida environment. Now, just off to the side here, I'm going to mute my microphone on rare occasion because I've got a frog in my throat this morning, and I apologize. So just give me 1 second here. Okay, I think I'm back. All right, so look, first thing we want to do is I'm going to show you the wall library that we're going to be using for this. So we're going to click and on draw, And then my menus are pulled down rather than the large icon cascading off to the side. This is what I grew up on, so to speak, and that's what I'm used to, and this is what I like. So we're going to pull down into draw walls, and when we do that, you're going to see a wall library here, starting right here at the top. Let me just scan just a bit. There you go. And you've got 8-inch block called bare block. Then you have 8-inch block with stucco and no drywall. Then 8-inch block with stucco, insulation, furring strips, and drywall. Then 8-inch block stucco on two sides that'd be used in an exterior wall arrangement. And then 8-inch block stem wall, and then an 8-inch block stem wall with a brick face. If you're doing block and brick or stick and brick and you're putting your home on a stem wall, you want the brick faces to actually line up from the stem wall foundation system to line up with the outside wall. Then you're going to see 2x4 wall, 2x6, 2x8, a series of those here. Won't spend a lot of time on that. And then you're looking at 2x4 and 2x6 in stucco, siding, hardy, 2x6 in siding with hardy, 2x6 with stone, man-made, 2x4, 2x6 in brick, stone, hardy, and brick and hardy. And then you're going to see a break here that says PT bottom plates. That means pressure treated bottom plate walls. So it's basically, I've reduplicated, that's a redundant, isn't it? I've duplicated the 2x4 and 2x6 walls down here to have a pressure treated base plate. The purpose of this is strictly for accuracy for the bill of materials takeoff report. If you're designing and you have no interest in an accurate bill of materials takeoff report, then either 2x4 wall will work, 2x6, 2x8, any stucco wall, it doesn't matter. But if you want accuracy for your bill of materials takeoff report, then this is the kind of library you would use. Moving down, you're going to see a whole series of existing walls. Remodeling is a big business here in Florida, and you want to be able to show for the building department what's called the as-built, which would be the structure as it exists now, and you would draw that and you would use the existing walls for two reasons. First of all, they're going to be accurate when you do the layout, but second, and they'll also show in elevation, cross-section, and 3D, but they will not count in the bill of materials takeoff report. Then we scroll down a little bit further and we're looking at miscellaneous wall types with poured concrete, 8 and 10 inches thick. Then there's poured concrete wall with poured 8-inch concrete 10 inches poured with a brick face. Then there's log walls, and believe it or not, there are 3 major manufacturers of log homes located here in Florida, the big one being BK Cypress Log Homes, and they use SoftPlan for their designs and they ship their products all over the world. SIPs are structural insulated panels. Generally, they're 7/16 OSBs filled up with 4 or 6 or 8 inches of rigid polyfoam, and then a panel on the opposite side, and they're used for construction purposes. Then you have screened walls. These are going to be used for pool cages. If you're not from Florida, if you have a swimming pool in Florida, you put a pool cage over it to keep the bugs out, keep the leaves out, and then you can enjoy your pool at night without being eaten alive by mosquitoes. Here's a party wall. This would be used for multifamily to separate for sound and fire. And then we get down into the steel stud system, 2x4, 2x6, 2x8. Some have pressure treated base plates, some don't. These are steel studs. These are going to be used for light commercial build outs in warehouses, restaurants, things of that nature. And then you get down into the ICF, insulated concrete form. I'll click on one of these so you can see it in section. So it's sitting on a spread footing. And here you're looking at the poly, and then the poly, and then in the middle, when I say poly, I mean polystyrene foam. And in the middle, you're going to have concrete. What's not showing here would be the grid of rebar that would be both vertical and horizontal. So this is our wall system, and you can see at the top there's a line here, and then you can see that there are some walls that have already been chosen. And when you choose a wall in SoftPlan 2020 or 2018, as you've chosen it, it moves to the top here, so it's easier to pre-pick when you want to move on to it again. But what I've done is something a little bit different. I've created what's called a palette. I'm going to zoom you in here so you can see it. And the idea behind a palette is that I don't have to necessarily use the wall library pull down at all. One of the most underutilized functions in SoftPlan is when you click on draw, you're going to see select, and there's an S after it, which means I could actually hit the keyboard. I'll clear it and hit S, and then I can hover on this and pick it, and now I can start drawing with it. So the select function allows you to, without having to use any pull downs at all, to create what I call a palette. And this palette is how I normally start my design process, and I use the select function. I hit S, click, drag, draw, everything's ready to go. I've done one other thing as well with this, and that is I've taken that individual wall and I will edit it for you, and I'll click on it, and you will see that it's 8-inch block and stucco. That's the note. So let me zoom you in tighter, and there is the wall type. I'll take you to the comment function, and you're going to, to the soft list function, and you're going to see that it's not included in soft list. So I have not corrupted, in this particular case, when I do my materials takeoff report, I haven't corrupted my materials takeoff with these little guys sitting over here on the side in my palette. Now, that said, I'm not going to use this. I'm just going to show you that this is something I do use on a regular basis. It makes life a lot easier and a lot faster. I'm interested in two things when I do a design. I want speed, but more importantly, I want dead accuracy. And that's going to come from a number of different processes as well. There's one more thing that I want to show you, and I'm going to open up my navigation tab here, and I'm going to bring up a chart, and this is going to be called a block dimensioning chart. So here it is, and what I want to show you is this. Oftentimes, I'll be looking into architects or designers' offices or even on a job site, and I'll see a set of plans that will have a set of dimensions on a design using Florida construction technique, meaning they're using block construction, but the dimensions across the overalls and between windows and doors and inside the rooms are showing fractional dimensions, which means, in my mind and in most cases, what's happened is that the designer took a stick frame construction design either out of a magazine or out of someone's office or whatever, and simply converted it to block. The problem with that is it creates havoc in the field for the block masons because they must do a tremendous amount of cutting. So they have to cut those blocks, and in the process, the labor rate for laying up block has gone through the roof because they're having an overall dimension, for example, of 58 feet, 6.5 inches is a nightmare for these guys. So every single block on every single course would have to be cut with a saw and then placed into position in order to match up with the design requirements created by the designer or the architect. So the right way, if you're in block construction, and this according to this chart, is that stick frame construction dimension protocols don't transfer to block construction. So if you follow these guidelines over here, you're going to find out that life gets easier in two ways. First of all, the construction will go a lot faster, number one, and number two, your block labor rates were going to drop dramatically because you won't have block masons cutting. One other thing is that once your wall heights with block construction get above 9 feet 4 inches, there's going to be a surcharge for the layup because those blocks have to be laid up using scaffolding, which means labor people have to take and pile the blocks onto the scaffolding, and then you're working off of scaffold. So many times you'll see most homes in Florida will be 8 feet tall or 8'8" or 9 feet 4. Those are all 8-inch increments as we go vertically, and it's based on the fact that once you get past 9'4", you're going to be paying a lot of money for labor rates. But that aside, here's the right way to do it. If your feet dimension are odd, 1, 3, 5, 7, 9, and so on, the following inch dimension should be 4 inches. So 1'4", 3'4", 5'4", 9'4", and so forth. If the block dimension across the back or an overall or in a room or whatever is going to be even 2, 4, 6, 8, 10, then the following inch dimension should either be 0 or 8. So 4'0" or 4'8", 6'0" or 6'8". You will never have to cut a block. You can either use a whole block or a half block, and you will find in several areas where we've actually tested this, you can save almost 2 days and block layup if you don't have to sit down and have somebody have to cut block to match up to what was used to be stick frame construction. So I'm going to close this just to let you know it's where we're headed. All right, so let's take back to the main floor, and I'm going to go ahead and just block cut this palette. We're not going to use it. I just want to go through it on a regular basis and show you how this is going to work. So let's start off with our draw. So we're going to go to the draw function. We're going to choose walls, and I'm going to take 8-inch block, stucco, insulation, furring strips, and drywall. So migrating from the outside in, you're looking at a block structure, you're looking at stucco that's going to be applied to the outside face of that. Then there's going to be insulation that'll be onto the inside face of that. Then furring strips, usually 1x3s or sometimes 1x4s, on that on either 16 or 24-inch centers, and then drywall tacked onto that. The insulation is only 3/4 of an inch thick, and most people's mind are blown when you tell them that my wall insulation is only 3/4 of an inch thick. But we're not northern here, so we're not worried about cold temperatures. we're worried about the differential between outside day temperatures and inside day temperatures. Outside, the temperature can reach 85, 90, 95 degrees. Inside, generally speaking, you're going to be at a 20-degree differential, so you don't really need a lot of insulation to make that happen. But if you're doing energy efficient designs, there's other ways. Let's move on. So I'm going to say okay to this, and now you have to pay attention to what's going on up here on what I call the enunciator. So the enunciator is saying that I'm drawing walls, and it's telling me that I'm drawing them out of 8-inch block and stucco with insulation, furring strips, and drywall. And if I wish, I can click this and pick a different wall altogether. I could also simply come out here into my clear space, and instead of using these menus, I could have right-key clicked my mouse, and I could have gone down to the wall menu and pulled it up that way. This is a very efficient and fast way as well, but also notice that it not only pulls up the draw menu, but it also pulls up the dimension menu, and it also pulls up the notes menu. So this is a fast way to go as well. One last thing before we get into this. This is your toolbar, and this is one of my pet peeves, and just follow me on this. When I install SoftPlan for our new users in Florida, I turn this off because for the following reason. Here's the classic case. On this toolbar that you're looking at, if I hover on that, that's telling me that it's edit an item. There's no other function on this toolbar, whether it's the one that came out of the box or the one that I created, that talks about editing. But if you click on the master command, you will see that there's a whole lot more you can do with editing than just editing an item. And most people have a tendency to fall back and use these shortcuts, but they don't necessarily always understand what they're shortcutting. So I turn this toolbar off. They don't even know the difference. And I force new users to use these menus. You learn the program by looking at the master commands. And then when you want to create your shortcuts, you have a broader understanding of what a shortcut could be for what your particular design requirements are. Now, you're probably thinking to yourself, okay, he turns them off, so how does he turn them back on? Usually within 4 to 6 weeks, I'll call those customers back and tell them there's a wonderful new function that was just added. All they have to do is go to their window command and come back and click on toolbar, and by golly, they've got a toolbar, and away they go. But by then, they've also gotten into the habit of using the master commands, okay? So I cheat. All right, so now we're back to draw. We're gonna choose walls. We're gonna choose 8-inch block stucco insulation, furring strips, and drywall. We're gonna say okay. And I like to draw left to right. That's just, there's no right way or wrong way in this program to draw, but there is a right way to get started with the first exterior wall. It starts with a click, and then I'm dragging my mouse out. And as I'm dragging my mouse out, what I want you to see is that that digital tape, let me zoom tighter, that digital tape measure is telling you in feet and inches how far you're dragging that wall out. You can see it changing. I'm going to zoom just a tad closer. Now, this is just for your reference. Don't try to draw using this tape. We're using a concept here called sketching for effect, editing for precision. Precision in this program, once you get used to it, is through editing. You sketch and you edit. Sketch, edit, draw, edit, draw, edit, draw, edit. That's your life. And once you get used to it, it's fast, it's quick, and it's easy. So I'm just going to click. I'm watching the tape. I'm going to drag out, I don't know, about 50 feet or so. And I've got a line, but I don't have yet a wall. And the reason is on this first exterior wall, the system wants to know where's outside. Well, outside is up. That's outside. So I click and the wall shows up. Then no clicking, pull to the new position. So I'm going to pull down to here and click. Now dimensions start to show up. Then I'm going to slide and click, 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 and click. Touch the Z key on my computer to get to where I want to go. And I'm going to enlarge these dimension numbers with Control Q so you can now read them. That command is also, if you go into, where did we put it? I forgot. If we go into options, you can enlarge your dimensions, and there's your shortcut, Control Q. So here they are. So here's my dimension chain, and I'm now going to start editing this dimension chain. And I do that by either right-key clicking on the item and choosing Edit, or I can go to Edit, Item, and click on the item and click, and it says that the current dimension is 73 feet 10 inches there, and then it's asking me, what do I want it to be? So I'm going to ask for 68 feet 8 inches. Those digits came from my numeric keypad, not from the standard keyboard. If you have a numeric keypad, it's a piece of cake. 68 minus key on the keypad, and then 8 plus key on the keypad gives you that information. So 68 minus 8 plus enter, 68 feet 8 inches. And don't forget enter. Don't just type in 68 feet 8 and then try to figure out what's next. Don't forget enter. Clears the data. Next, these arrows. These arrows are asking you which end of the dimension chain do you want affected by this 68.8. It's not which way, it's which end. I want this end affected. So I touch that right arrow and this wall will move back to give me an overall of 68.8, just like that. And then what I do is I go around the other side, there's 59.3. Well, I'm going to use my guidelines I showed you earlier, and I'm going to make that 59 feet 4. It's an odd foot, should be followed by 4 inches, and I'm going to move the bottom of that line. Then I'm going to swing, and notice that this chain is broken. Don't worry about it. It's not a big deal. Move along the base. I'm going to go to 28 feet 8 inches, and I'm going to move to the left side to make that work. Then I'm going to get a gap down here. I'm going to go to 14 feet 8, and I'm going to push that way, and what's left is 25.4. What's left is exactly what block dimensioning should show, 25 feet 4 inches. It's perfect. Then we'll come up and we'll go to, let's go to 10 feet on this. I'm probably going to pay the price for this. I collapse that a little bit, and then I'm going to take this up to 10 feet, push that up, and then what's left is 39.4, okay? And then I'm going to come across the top, and I'm going to set that to 16 feet and just push it that way. That leaves 52.8. That's perfect. The 6'7", I want a bigger gap than that, so I'm going to bring that down to 10 feet, push it down, and there now is my preset, pre-dimensioned, everything the way I want it to look from the get-go. But the dimension chain is broken, obviously, so I go to dimension command and I say, please re-auto dimension this drawing. And it said, well, this could erase some of your existing dimensions. Well, I'm hoping it does. So I click yes, and everything is back to where it should be. And by the way, when I say back to where it should be, I mean to AIA standards. So if I turn off the enlargements, that means that that number is sitting where it's supposed to. The gap between the outside face of that wall and where that dimension number shows up is preset. The gap between here and here is preset. The number placement is preset. Those all follow the AIA, American Institute of Architects protocols. That was a big breakthrough for us because it was one of the things that helped accept this product in some of their design operations. Okay, so this is my first floor. It's laid out. And what I'll do now real quick is I'm just going to go in and show you a 3D model of this. So I'm just going to go to the model command, and I'm going to come down and I'm going to say I'm going to ask for a 3-dimensional model right here. I like textured. It's fast. It's easy. I get shadows, but it isn't perfect, but it's close enough for what I'm doing. So I click textured, and it says, okay, if that's what you're after. There is my house floating in the sky. All right. So I'll take and just roll you in closer like that. I'm just using my up arrow key. Now, pressing my right mouse key and holding it down, I'm going to drag it up. And then holding the wheel down on my mouse without rolling it, hold the wheel down, and then I'm just going to move the mouse, and that'll tip it. One of the things here that's a distraction is this sky. So I'm going to go into the mode for options, going to go to mode options here. And I'm going to take the background. I'm going to say, just give me a color. I just want this to float in free space. There you go. That's all I'm after. Okay. Now, so we have a 3D model. We have our main floor. And in this particular case, I haven't added any windows. I haven't added any doors. I've got a footprint. This is going to be a 2-story structure. And the 2-story structure that I'm going to create is going to sit between here and here. So what I'm doing is all of this down below, down in this area, will be exposed on the first floor, and this bump out will be exposed on the first floor. So this space in here will need its own roof system, and this space will need its own roof system, and the second story, which will occupy this rectangle, will have its own roof system. Here's the easiest, fastest way to get a second floor. First, file, save all. Before you do anything, save everything before you go. Next, this is the active drawing. It's illuminated. I'm looking at it. File, save as. Save it as what? Save it as second floor. That's what I'm doing. So what I'm showing you is this. I'm not going to draw a second floor. I'm going to generate one. Now you're saying, yeah, but it looks exactly like the first floor. Yeah, you're right, it does. So what I want to do now is take this second floor and modify it to the size that I want. So to do that, I go to my tools command and I use the fillet tool. If you're a CAD user, this is a common term. If you're French, like my wife, she calls it fillet. So we're going to fillet or fillet, whatever you want to do. We take this and we say, okay, this wall click will now join this wall click. And this wall click will now join this wall click. All this other stuff is extraneous. So I'm going to use block erase. I'm just going to glide over this and boom. Block erase says only whole items contained in the block will be erased. I'm going to zoom this up so you can see it. Now what I have is my second floor. However, it's block construction. I don't want block construction. I want stick construction. 2x4 and stucco to be precise. So I'm going to go into the edit master command. This is why using the master command counts. Change wall. Okay, it says, well, all I can find is 8-inch block stucco. Yeah, that's what I want. Okay, change it into what? Change it into 2x4 and stucco. Okay, and then the $64,000 question. All right, you want to change it, but how do I take this 8-inch block wall out and put in the 2x4 wall so that you don't have to redimension this thing? Piece of cake. I want the outside of the current wall's outermost load-bearing material, that means the outside face of the block, to line up with what? The outside face of the stud of the incoming wall. Okay, it's done. It's done. So now if you look at this, you'll see that I have a 2x4 wall construction system that's set up for my second floor. But there's something else that's going on here as well, and that is there is no floor system under this. We'll take care of that in a minute, but I want to make sure that this wall system anchors the way it's supposed to. So what's missing in my open diameter here, or my open parameters on my toolbar, is the first floor. So where am I? Well, here's the main floor. I want to open it. Well, now it's out of sequence. Here's the second floor way over here, and here's the main floor way over here. So click and hold and drag it back. So here's the main floor. Here's the second floor. You can see the difference. And now watch one more thing. If I go to the model command and I want to model this, the only thing that's in the model command is the main floor. So if I took you back and opened this 3D model again, that's all I've got. Yeah, but if I come back to this navigation tab and I take the second floor, click and hold, and drag it up to the model, now look what happened to that 3D view. You see what you have? You have two floors here. So, and if I click on the model command, you're going to see that the assembly is complete. All done. Thank you. All done by using the drag and drop function by simply taking that second floor and main floor and dragging, or the second floor and dragging it into the model. Drag and drop, beautiful system, works great. Second thing we have to take care of now, and that's this. We're going to go to the second floor, and we need to put a floor system under this. So in order to put a floor system under this that makes sense for Florida construction, we're going to use a webbed floor truss. So now for the first time, we're going to be changing modes. Look where I am here on the top right screen. The active mode is the drawing mode. We're going to come down and we're going to ask for a floor system. And the floor system, that's where we are. We're going to come over now, and when we change mode to floor system mode, we come back over here and we click on the draw command, and you will notice a new function here that's included in the 2000 series of SoftPlan. It says floor system options. If you're a relatively new user to SoftPlan, get into the habit of when you change modes, and then you click draw, go down and check your options before you draw anything. So here are the options for my floor system. It's set for Florida already. We're going to be using a 16-inch deep floor truss. Those trusses are going to be 3.5 inches wide because they're made out of 2x4s. We're going to place them on a 24-inch on-center basis. We're going to use a ring joist system, a flange, and a webbing system, and that will be a floor truss. All right, and we're going to be using pressure-treated plates, not in this case, because in Florida, when you put a floor truss on top of a block wall construction, the truss manufacturer puts a stainless steel plate on the bottom side of the truss so you can stand it on the concrete without having to use pressure treated material, and it's forever. Then you come down and look at the thickness of the subfloor, 3/4 of an inch, that's Florida building code. If you're going to insulate it, that's fine. The continuous value versus the cavity value. If you know anything about energy related situations, especially for using res check, timber, wood is not a good insulator. So the cavities will have an R30 value, but the combination of the cavities with their insulation and the wood themselves, the wood degrades the overall continuous R value and takes it down to a 25. That's not bad, not worried about it. I'm going to simply say okay, and then I'm going to go to the draw command and I'm going to draw a floor system. So when I click on it, it's asking me, what do I want? Do you want joist? Yes. Ring joist? Yes. Sill plate? No. Do you want a subfloor? Yes. Do you want automatic? Yes. What do you do? Click. Thank you. It's done. And when you roll in, they're all labeled. You can see that floor truss 1 is 3.5 by 16 by 29 and 2.5 inches. Not only is it all done, but you'll also see that all of the other information is in there as well. And if you come down across the bottom, there's one other important thing to keep track of, and that's these little dots. The J stands for joist. The SF stands for subfloor. And then if you look at this, RJ is the ring joist. You can edit the properties of those individually. Over here on the side, there's a little arrow though, and that's called the joist arrow, but that's called something else. So let me show you what that does. We're going to click and edit this. We're going to go to edit item and click on this thing right here. And it says, is this the new reference edge for your joist set? And if you say okay, the joists flip. That's how you control which way they go. So I'm going to undo that and put it back the way it was. So now if I go back to my 3D textured model like this, now when you see it and you look down inside, you're looking at the subfloor that's already laid out for you. And if I come into my extraction options on my 3D model and go to framing, and I ask for floor system framing and I say, okay, what I'll now do is I'll go in and I'll dissolve or make disappear the subfloor. So I go into the material visibility function under options in 3D, and I'll come down and I'll say, okay, here's what I want to see for structure. Just turn off the subfloor if you would. That's all. I don't want to see it for the moment. And you say, okay, and voila, there are the trusses. Now, if you really want to get clever, you can line this thing up and you can use your up arrow key. There'll be a small crashing sound as I break in. Oops, sorry about that. And there they are. And then I'm just holding down my shift key and going down below. So here I am down below, and here I am above. And then if I come down below one more time, what we'll do is we'll come back in and we'll say, okay, all these shadows are being cast by the sun, obviously. We'll come into our options, material, and we'll go to structure, and we'll say, turn the subfloor back on. So it says, okay, well, the subfloor is back on, and voila, those shadows disappear. And then as I go back up top, there it is. Cool. Okay, let's go back to the main floor. There's something else I want to do to this main floor right now. And what I want to do to this thing right now is this. I want to raise these wall heights because 8 feet isn't tall enough. So I'm going to go into the edit command, again, a master command, wall height, click, drag a box over the entire structure, and tell that new wall height to be 9 feet 4 inches tall. Okay, so what just happened? Everything just happened. Those walls are now taller. You probably didn't see it because it happened instantaneously, but you can begin to see the difference in the wall heights from the first floor and the second floor. And the reason that this looks a little taller is, don't forget, we brought our stucco down over the joist set, so it's covering it all up. That's all there. One last thing before we get too carried away here, and I have a tendency to do that, so Jimmy will be blowing my ear if I'm doing this too slow. We're going to put a monolithic slab underneath of this quickly. Here's how it works. We're going to, again, put this into floor system mode for this drawing. Okay, and then we're going to go into draw, and what are we going to do? Check the floor system options. So when we do that, now we're going to be looking at the slab information. So we want a 4-inch pour, and in Florida, the inside joke is good luck if you can get the guys to pour it 4 inches thick. We do not use rigid insulation under our slabs in Florida because we don't have frost issues. Our footing thickness is going to be measured from the bottom of the slab to the bottom of the footing, i.e. 16 inches deep. And the width of the footing is going to be 18 inches wide. There's a tremendous amount of sandy soil in Florida, and we need that to be deep and wide so that we don't get any shifts. If you're building in Arizona, you wouldn't use a monolithic slab. You would use a post-tension slab. Desert sand out there runs forever. and post-tension slabs would be 8 to 12 inches thick, and they would have a cable system running through it end to end on all four sides, and they would be tensioned. And the idea behind that is that when heavy rains or monsoon rains come and the sand gets washed away, the building doesn't crack because the footings have disappeared. They stay in place. That's the concept anyway. And we're going to do one other thing. We're going to make this a structural slab. And in SoftPlan parlance, that means add the monolithic footings. Okay, so what are we going to do now? We're going to go to draw, and we're going to go to slab, and we're going to say auto, and we're going to click, and there you are, slab with footings. Each of these dots, edit, can control the properties of that slab footing. So you can see how wide, how deep. We're not going to be recessing the wall above. In Miami, you would recess the wall above because it creates a notch, so to speak, of 1.5 inches that creates what's called a water dam. And that ensures that in case of some minor flooding, the water doesn't seep under the block, between the block and the slab. There's an 1.5 inch thick dam here that would stop that. So we're not using it here in Central Florida. It's not required. So I'm zooming you back out. There she sits. We're going to put this back into drawing function. We're going to zoom it with the Z key, take you back to the 3D model, and then now you will see that the monolithic slab has been added. I'll tip you underneath the building. There are the footings all the way around. Some of you might be designing structures that may require, in some cases, a reinforced footing. And I'll give you an example of that. Perhaps there's going to be a load-bearing wall across here from the top floor. In our case, there is. So we're going to come down here and we're going to put this into floor system mode yet again. And I'm going to pour a reinforced footing across this gap and across this gap to carry the load, help carry the load from the second floor. So we go to draw, we go to slab footing, we just simply zoom in close, get close, click, drag, click, there's the footing, and we'll do it again down here. Click, drag over, click, there's the footing, and then we'll zoom it back so you can see it, and then we'll take you underneath the 3D model again, and you can see that we've added those two reinforced footing systems to carry the load from the second floor. One last thing to make certain that everything lines up properly is that, thanks Jim, is that we're going to come back to the main floor and we're going to put this back into what's called drawing mode. And I want to do one other thing to make certain that the alignment between the second floor and the first floor is perfect. Now, there's no reason why it shouldn't be, because they came from each other. The second floor was generated from the first. But to guarantee it, we're going to go to draw reference points, and I went fast, I'm sorry, draw a reference circle, and I'm going to zoom in close to the corner and pop it right there like that. And then I'm going to take you out to the second floor. I'm going to put this into drawing mode. I'll zoom it up so you can see it. And I'm going to go to draw a reference circle, use the same one, and I'm going to put it in the same place. I'm going to take it in tight so you can see it. Notice how it attaches to the structure, not to the stucco. We'll zoom it back out, and we have guaranteed that our alignment is perfect. Last thing before we get too carried away, I'm going to take you back down into the main floor. And what I want to do now is I want to go in and put this into ceiling mode. I'm in a hurry, so I'll do it quickly. I'm going to go to draw a ceiling, not a ceiling system, but a ceiling. And to do that, I simply say auto trace and I pop a ceiling system in. Now I will edit this ceiling system to get its properties. And by the way, here it comes. It's a horizontal ceiling. It's textured. It's made of drywall. I want it painted in this particular case. I will add insulation to that. I'll give it a depth of 17 inches. That's fine. That's enough. And then, actually, that's too much. I'm going to take it down to 15 inches because I've got a joist system above it. And I'm going to say, OK. And then back to the 3D model, you can see that my ceiling system has showed up. There it is. And if I take you inside this building now, like we did before, boom, and then I'll take you down by holding down the shift key and take you down inside. And I think you can see the ceiling there. So we're covered. OK, let's back out. We're out here. And then lastly, what I want to do is I'm going to put a roof system on this. And then we're going to spend a little bit of time on putting in a stair system that'll come up from the first floor and make contact with the second floor. And let's do that now. So let's get a roof on here first. So we're going to go back to the second floor. And whenever you have a two-story structure, the easiest, fastest way to put a roof on is to use the multi-floor roof function. And it's really simple. All you're going to do is you're going to put this in roof mode, just like that. Boom. It's now in roof mode. Great. And then what we want to do is we want to go to the draw command and do what? check the roof options. So we click on roof options, and this is a complicated screen, and I will warn everybody who's listening, we have a tendency to glance instead of read on our dialogues. There's a lot of data here. You must get into the discipline of reading what you're looking at until you're familiar with it. So we want to see right now what our current roof properties are. We're going to go with a slope of 6/12. We're going to have an 18-inch overhang, which is calculated from the structure. Keep that in mind if you're doing brick construction, because brick is not considered structural, and the overhang will be calculated from the stud or the wall. The gable overhangs are predetermined. The heel height for the truss is set to 4¼ inches right there. I'm not using an energy heel in this particular case. The side, it says that, let me pull this down so you can read it. The gable end finish is defaulted to siding. I'm going to make it default to stucco. One last word of caution: in Florida, you don't see a lot of gable ends, especially as you get closer to the Miami South Peninsula part, because hurricane wind speeds go up. And when you put a gable end up, you're sticking a sail up into 140-mile-an-hour wind. And I'm here to tell you that roof is going to come off. So you want to use hips wherever possible. And then the shingles are already laid out. The roofing material shingles, we're going to add automatic ridge caps. We're not going to have any profiles to worry about. No purlins here. We're not going to put gutters on this. That's an option. Our roof decking material is 7/16 OSB. Our framing will be trusses, and they're on 24-inch centers. And I'm not going to lay out a truss pattern, but your truss choices are now attic, fink, howe, king, queen, and vertical trusses. This is new. Vertical trusses is new for 2020. Attic trusses is used for attic space or bonus rooms. We'll get to that later. I'm just going to use a fink truss. I'm going to say okay to that. And then I'm going to go to the draw command, and I'm going to ask for a multiple floor roof. When I do that, it automatically adds the floor below. So when I zoom it up, you can see in the different colors here what's what. So the floor below is here. And then I go to draw, and I do, in this particular case, I use what's called trace a roof. I trace over the main floor first. Notice how I stay slightly outside to the corner, slightly outside to the corner, slide back over, and then close. Oops, sorry, went too fast. Try it again. All right, take your time. Slide over, click, and close it up. Boom, there's your roof. Proof, there's your roof. Here it comes. Nicely done, including the ridge caps. All right, let's go back to our second floor yet again, and now let's put a roof over this bump out, and let's put a roof over this bump out. So we're gonna go to draw, and we'll add a roof. Trace again. I like to zoom in tight, start to the outside. Look at my cursor crosshairs, how they kind of mimic the overhang. Click, drag, come back and make contact with the wall, period. Slide across and close it up. Boom, there's your new roof. Do the same thing down here, zoom in close, don't work far away. Click, click. Some people will use the add roof function. I like to use the trace function. Contact with the wall, slide across, and then close it up, and boom, there you go. And now if I take you back to the 3D textured model, everything is roofed the way it's supposed to be. And you have a 2-story structure with a roofing system that's already built in. You've got floor structure added between the floors. You've got a monolithic slab holding up this entire structure. And we'll show you a little bit about BIM here. Not a whole lot, but quickly, because I'm running out of time. We're going to go to draw and opening. And one of the openings that I'm going to choose is a garage door. And you're going to notice that I have garage doors set up for Florida construction, which is masonry construction, which is going to look like this. So I'm going to come down and I'm going to grab, actually, you're supposed to be using solid doors. I'll use that. And I just get close and I click, and there's my garage door. It's in. We'll get to that in a second. And then what I want to do is I'll say okay to that, or I can come back over here and say, okay, there it is. But what just happened on the main floor? Well, let's put this thing back into drawing mode, and you will see that the garage door has been added. And if I go to my auto dimension command, you will see that I've got it in place. Now notice that 16-foot garage door becomes 15.9, because in Florida, the garage door with block construction sits behind the block, not between it. And this is where your tracks would be and your bucks. I've got my bucks turned off, by the way. And you can make this a full 16 feet if you wish. You can edit that 15.9, and you can say, okay, you're 16 feet, and then have it affect both ends simultaneously. And now you've got a 16-foot, 6-inch garage door with a 3-inch overhang on either side. That's typical Florida construction. Let's go back into our 3D model real quick, and let's put an entryway in here, put a couple of windows in on both floors, and then I'll walk you around the back, and then we're probably going to run a quick bill of materials takeoff report. And then I got to get the stairs in. So let me do this quickly. So we're going to go to draw an opening. We're going to be using an exterior door. I'm going to use Colonial. I'm going to use, in this particular case, a 3/6 door. I got room for double doors. I might use a double. Let's come down here. Here's the 7280. Let's use this one. That's pretty cool. And then we'll go pop. There it sits. And then what I want to do is draw some openings. We'll go to draw openings. We're going to use windows. You'll see a different change here as well. Single hung Florida windows. Aha. So what kind? Well, masonry construction. Made by who? Better Built and PGT. Those are the two largest window manufacturers in the state of Florida. We could go to PGT. That's their product code. We could go to Better Built. That's their product code. I'll make it quick. SH25 double mulled. I'm going to put one here. I'm going to put one here. I'm going to put one around the corner. I'm not really paying a close attention to all that. And then what I want you to see is that those windows seem to be higher than the door, and they are, because they've been told, watch, they've been told that the offset, I just edited that window, that the offset from the top of the wall to the top of the window is 1'4", or from the bottom of the wall to the top of the opening is 8 feet. I want it to be 6'8". That's even course block construction. See that window come down. And then what I want to do is I want to repeat that edit to that window, and they're now down where they belong. Fine. Now I'm going to put some windows across the top, draw openings. These are going to be different. These are going to be stick frame windows. And I'll use Better Built again. And we'll just use some SH25s. Where are we here? 3050. Notice the nomenclature is in 4 digits instead of 2 digits. Okay, 4-digit window codes are by definition stick frame construction using a thin rather than a flange. Okay, so we take you back into the main floor, and you can see that windows have been added. Watch my select command right there. Select. I'm going to grab it. I'm going to put another one in. One's going to go here. One's going to go here. Down here, down here. And that's close enough for this exercise. Maybe one here and one over here. And then what I want to do is I'm going to zoom you in close, and I'm going to set these dimensions so that they make sense for block construction. So I'm going to unenlarge these numbers, get in tight, and I'm going to tell that number to be 4'8", and then what's left is 5 7/8. Gang, that's because Better Built gave a rough opening of 6'3" and 1/8. And that's the correct rough opening, because why? There are going to be mounting bucks of 1.5 inches that have to be put in here, and then the window's going to be bolted to the wall, excuse me. Now we can go in and edit this and tell it to center itself, which it does, and then you get at least even dimensions on both sides. But now I'm cutting block in 2 places, here and here. It's easier sometimes to simply say, just make that 4'8". And on that side anyway, no block cutting, there'll be some over on this side. Coming down the side real quick, I'm just going to set these dimensions. Just bear with me here for a minute. I'm going to go to 10 feet. These are perfectly random. Normally you would put in your interior walls first so you don't get screwed up in terms of where the windows are. I didn't have time for that. I'm going to leave that the way it sits. Coming down here, we're looking at these numbers. There's 4'8", close enough. Push that. And then I'm going to make that 5'4", push that. When I say push, I'm touching my arrow key. You can see that we've got an odd dimension there. That's the way it is. And then we go to edit. We'll click on this door. We'll center it. And it says, well, along the outside or the inside? It depends. I'm going to center it to the inside. So when you're standing inside the house and looking at that door, it makes cosmetic sense. You get these odd numbers. I think what I probably would do to get rid of the fractions, I'd say this is going to be 3'4" and push that. That gets rid of the fraction on this side. Okay, and then the garage door is automatically centered. When an opening takes up more than 55 or 60% of the available space, it centers itself. I'm going to come up along the side here and go to 21 feet 4 and push that. And then I'm going to go to 10 feet on this and push that. And I'm done for this exercise. Now, last thing, I want to put a set of stairs that when you come in this door, there's going to be a set of stairs. This is my garage, obviously. But when you come in this door, I want to have a set of stairs sitting here that take you up to the 2nd floor. So in SoftPlan, here's the rule of thumb. If you have 2 floors that are already assembled in the model, we do. If they both have floor system in them, they do. Then the stairs will automatically calculate their floor-to-floor heights for you. So I go to draw, I go to stair. I'm going to use something really simple. I'm going to go in and grab a straight stair like this. I'm going to make a 42-inch wide that looks like this. By the way, you can hold your wheel down and you can examine that by twisting that around too if you wish. Click OK. I'm going to come down in here and I'm going to put the stairs right about there. Watch, I'm going to back up so you can see. Watch what happens when I click my mouse. Watch. Get a little tighter to that wall. Click. See how that grew up? When I say grew up, it ran up. So look, when I look at this now, check it out. The height of this stair is 10 feet, 8 3/4 of an inch. If you do the math and you take 9'4" walls and you add 16 inches of joist depth and 3/4 inches of subfloor, those stairs are in the right place at the right time. They are actually moving to where they're supposed to go. They have calculated their floor-to-floor distance for you. I'm going to push it out of the way a little bit. And now watch what happens. We'll zoom it so you can see it. Take you back to the second floor, zoom it, and then we're going to take and put this into floor system mode. And now I'm going to go to draw, and I'm going to do, in this particular case, you can do with an overlay, and it says, what are you overlaying? It's suggesting the main floor, and look what you got. There's your stairs poking through. Okay, so what's next? Good alignment on the joist, huh? Lucky move. Go to draw, and now we're going to go and we're going to put in a stair headroom clearance hole. This is an automatic system that's built into the program. Click on it and just click. And presto changeo, there you are. We have built a stairwell. And not only have we built the stairwell, but if we take you in really tight, you can see, I hope, that you can see the joist hangers right there, right there. You come down here, you can see the joist hangers. There they are, there they are, there they are. One last thing to get this right, we're going to edit this hole here, and we're going to tell it to add drywall. Boom. Okay. Now that that's done, we're going to come back to the main floor. We're going to do a quick cleanup. Don't forget cleanup, powerful tool. Take you back to 3D. Everything has changed dramatically here, as you can see. I'm going to take you inside, I think. Here we go. Big crash as we go through the wall, sorry. Boom. Didn't happen, did it? Okay, there's my stairs, and notice my stairwell is cut, my ceiling board is cut, and if I can pivot this around, you can also see that my stairs go all the way up to the second floor, and if I migrate you up, there you are. Now all I got to do is build some railings up there so I don't kill my workers as they walk around and fall down the stairs, but there you go. Everything is finished. Okay, lastly, I want to take you into the building materials takeoff report. And what I want you to see before we do anything else is that there's a series of warnings at the bottom of the screen, and it's telling me what I have not yet done. It says, warning, the main floor doesn't have an insulated floor. Fair enough. Warning, there's no garage walls found on here. Well, it saw the garage door. Where are the walls? It says the roof isn't found on the main floor. That's because it's all on the second. Warning, there's no vinyl or carpet or hardwood. There's no baseboard. There's no trim. There's no total area calculation. There's no filled cells. Explain that in a minute. There's no ceiling board found on this plan on the second floor. Okay, there's no main floor, doesn't have an insulated floor. We went through that. There's no garage walls. We're getting that information. We scroll down deeper. Here are all the same warnings. So we're doing it floor by floor. Those warnings are what I like to say in SoftPlan parlance. Don't hold, the materials takeoff report is saying, don't hold me responsible for my lack of attention to detail. So we'll scoot down here real quick, and now you're going to see the concrete in the slab, the rebar in the footing, the wire mesh, the visqueen, concrete blocks estimated versus blocks consumed. The block masons always calculate solid block counts. They don't care how many doors or windows you got, but that doesn't tell the builder how many blocks he actually used. Okay, lintel blocks, those are the construction underneath the windows and the doors. Steel supports, block wall labor. You got soil treatment, termiticide, ring joist systems. We're looking at the second floor, all of the furring strips on the first floor, second floor, the headers. You're looking at the roof decking material, plywood H-clips to hold it on. Your fascia cladding, eave starts, valley roofing, roof flashing, dry-in, called roofing felt, 30-pound, required in Florida. Shingles in squares, that's the right way. Ridges in linear feet. Then you're looking at how much wire lath was used on the second floor. Because it has stucco, you have to have wire lath on the sheathing to hold it in place, including some sort of Tyvek or house wrap. That's all there. And then it's looking for these other products. There's the doors. There's our garage door. Square up shims, entrance hardware, garage door opener, insulation, furring strips, vapor barriers, garage door mounting bucks, exterior paint, drywall, screws, compound tape. I'm running out of breath. Paint on the ceiling, and walk-through inspection. Real quick. This will be real quick, and then I'm done. Oops. didn't mean to do that. Let's bring it back to SoftPlan. That'd be nice. Okay, let's go back to the main floor. One last thing required in Florida is filled cells. So I'm going to go to draw. I'm going to go into the symbol library. I'm going to take you into the structural library, and you're going to see something called filled cells. These are concrete that is poured from top to bottom of the wall down the cell of a given block. I'm going to say okay on the 8-footers. I'm going to roll in. It's going to look like that. Boom. Now I'm going to make at the corner, you need to actually make 3 of them, 1 to the side, okay, and then 1 down below, okay, and then they have to appear every 4 feet, okay, and I just take this guy here, and I'm watching my tape measure up there, and I'm going to go, well, to the nearest opening, that's close enough. Boom. You need 1 there, and then you need 1 on the other side of that opening over there like that. Okay, fine. And you would populate the entire first floor with the correct number of filled cells on 4-foot centers or on either side of an opening. But here's what just happened. If I take you back to the bill of materials, what I want you to see now is I'm getting rebar in the filled cells, the dowels that hook the filled cells to the monolithic slab, inspection plates on the top and the bottom to make sure that the concrete went top to bottom, how much concrete was used to fill up those cells, how much pump mix was used along the top, and then how many filled cells were actually used. Okay, so that's basically a quick 1-hour run through as to how things are done in a Florida environment. I didn't get a chance to spend all the time I really wanted to, but that's probably as good as it's going to get for a 60-minute presentation. There you go, Jim.
Thank you, David. Ladies and gentlemen, thanks for joining us today. As I said, I will take this video and we will get it uploaded to our webpage, and you'll be able to review. There's a lot of information in there that David threw out. And David, is there a way they can contact you for any further information about this?
They can. They can contact me at dwilson, like in David, dwilson@softplan.com. If you have any questions or comments, by all means, I welcome them. Send them to me and I'll answer them as soon as I get them. And it can be about any topic you saw today or any topic that's about anything doing that we did in the design here.
Thank you, everybody, and we hope to see you in future classes as we pull these together. Have a great rest of your day, and see you soon.
Thanks, Jim.